For example, fluoride ion, chloride, bromide, cyanide, NO2 minus, hydroxide ion, ammonia molecule, water molecule, carbon monoxide molecule, nitric oxide, pyridine. B. Bidentate. Such a ligand has two donor atoms so that it can bind to the central metal atom or ion at two locations by forming two coordinate bonds. Examples are NH2, CH2, CH2, NH2, that is known as ethylene diamine. Next is 2,2-bipyridine with the structure given. Another one is NH2, CH, CH3 in the side chain, then CH2, NH2. Its name is 1,2-propane diamine. Similarly, oxalate ion, that is C2O4 2 minus, glycine anion, whose structure is shown here with the formula NH2CH2COO minus, and carbonate ion CO3 2 minus are examples of bidentate ligands. C. Tridentate. Ligands with three donor atoms. For example, H2N, CH2, CH2, NH, CH2, CH2, NH2. That is known as diethylene triamine, or according to IUPAC, its name should be N2-aminoethyl 1,2-ethane diamine. D. Tetradentate. Obviously, ligands with four donor atoms. An example is NH2, CH2, CH2, NH, CH2, CH2, NH, CH2, CH2, NH2. Traditionally it is known as triethylene tetraamine. Similarly, there are pentadentate, hexadentate, or in general polydentate ligands. One good example of a hexadentate ligand is the tetraanion of EDTA, that is ethylene diamine tetraacetic acid, with the structure given below. Multi or polydentate ligands are also known as chelating agents if on coordination with the metal a cyclic ring is formed. For example, ethylene diamine, which is abbreviated as EN, forms a complex with platinum second as PtCl2En. Then it can be expanded as shown below. So here, ethylene diamine En is forming a 5-membered ring, hence it is behaving as a chelating agent. Some ligands are known as flaxidentate because their denticity is variable. For example, EDTA may behave as hexa, penta, or even tetradentate ligand depending on the conditions. Similarly, sulfate ion may behave as mono or bidentate ligand. Some ligands are called ambidentate, which have alternative donor atom. For example, cyanide ion may bind itself to the metal through carbon or through nitrogen, depending on the conditions of coordination. Similarly, NO2 minus may bind through nitrogen or through oxygen atom.